Uh, this is the implementation of RAG, which is a retrieval of augmented generation using large language model, which is basically mean it's help to optimize the response of LLM. So let me explain my code base step by step. So I have utilized Tesla D for GPU time, GPU, and for extracting the PDF, I have utilized this library by PDF to extract my data set from the book called Human Nutrition book 2220 edition. I've already shared my link to my data set, which is this, and I have utilized files library by dataset database. It also utilized by Facebook, and I also installed sentence transformer because I have been using transformer to create some embedding. So the sentence is extracted here. So this variable store the part of my PDF, which is this book, and this function extract the sentence from the PDF one by one. I have tokenized these sentences, and this variable store all sentences, and these are the total number of sentences that are extracted from the book, which is 1200 2268. If you move down, import file by an MP sentence. So this is the embedded model which I have used all MP NetBase v2. It also available from the hub interface and with the help of this I have generated embedded for those sentences which I have showed. As mentioned before, I ended to prove their such similarity and not to redo the code again and again. I have stored them in a database which is Spice. I have utilized this open source database. You can see these are stored successfully now to my text code base, which is about to extract the similarity score. So basically I have extracted top 5 chunk, and this is the chunk query I've been given to the database with what are the benefits of the nutrition. So it encode with that query and load the top 5 chunks, return it, and you can see that what nutrition is important. This is the sentence, these are the result accepted, and whatever is the nutrition on the top chunk. Obviously the top 5 chunk will contain the 7 keyword from the security, and given the distance, so the distance closer to the one is actually very close, and I have extracted top 5 chunks. So obviously the distance needs to be greater than 0.5, and you can see it's 0.7, 0.8, 0.2, 0.84, and so 0.85 to each word that contain nutrition on or any other keyword that is present in our query search is going to give the similarity score with the higher index. And normally, because normally similarities are often used by LLMS, or to get the similarity score effectively. And let me show you the shape of embeddings. You can see this is the shape of embeddings. These are the actually matrix, usually UV matrix, and these are the sentences extracted from the scope. So this is the representation of embedding. As you can see, it will not show fully because obviously it is not show fully right now, but you get the point. And then again, let me show you. For example, I have this sentence along with their embeddings. For example, for the first place, contain the name of the book given Nutrition 2022 edition, and these are the top 4 5 sentences which are these are embedding representation of those sentences. So just like that, you can see the embedding generated like this, and then again I have given this a new query which is a micronutrition. Nutrition function. So I have tried to incorporate some timestamp as well here. So time taken to score on this much embedding is this, and this was a number of millisecond normally to exact this, and you can see the score of this. And this is because this was a chunk extracted, so on the basis of chunk is for the score given. So again, this is something interesting to see, uh, chunks with the score, nutrition with the score, and also sometimes you can see, even see the chapter number as well from which after this was expected. So I've given some more example ahead. So the normally when you are dealing with LLMS, the very important thing to present the data. So utilizing previous project function, I have pre-processed data to to clean it further and give it to the model. Again, this is the function to find the page number and highlight the query term. So let me show you some representation of representation. So as you can see, this is a query. I have just a sample of keyword carbohydrates, and I have amended it, and this is the whole process. I have done it whenever it given the query carbohydrates, so it highlight the word carbohydrates, also give the page number and the score of similarity and carbohydrates chapter number 4 page number, and these are the probably the preface of the book which is contain the chapter information. So again, carbohydrate is as a carbo and hydrate. The word carbo means carb and hydrate means water. Can you see the carbohydrates are highlighted because that is the theory, and the that was the query, and this is the similarity score, and the similarity these I have most I think this is the top 10 chunks I guess. So yes, I have displaced 10 1010 chunks regarding this query, and then the next step is once it's done, next step is generation. This is these are the my exact SS token I have utilized to extract the model large language model, which is gamma IB7 IT for the generation of the text for from the given theory query. So I have also, in order to optimize my response time, I have quantized the model, and I have made it auto as well. So you can see the optimizing the RAM in the meantime, because the installing this take a lot of time and lot of memory consumption when you are in the time environment as such. So the utilization to improve the performance, utilize to improve the performance of LLM. I have utilized forward quantization to improve the memory efficiency, and let me show you what example I have done. So input assess what are the micronutrient and what goes to the plate in the human body. So what was the input text, and using the tokenizer I have generated the response, and I also set some parameter like 500 maximum token. So I have set some parameter, for example, I said max new token has to be 500 with the temperature up to 70%, 0.7, which is like more diversity inclusive, and then top 5 is 0.9, which repetition penalty has to be 1.1, and I also ensure that these sample are accept receptor group. So as you can see, this is what was the query. So what are the microcarbons and what the role of they play in the body. So we are actually getting very rare response from the model gamma 70b. It's the nutrients, carbohydrates, protein, and monitoring, which are the macronutrients, provide result with an adjustive function properly. Each one play a different role. So again, because token was 500, so it is generating the most robust response here, like carbohydrate is giving definition and provide glucose and how much similar and there in the body. So simply the protein and so far for it as well. So finally there, like you can see the last of mention there are double stack highlighter return, and so these are three micronutrient work together humorously ensuring optimal health is balancing properly according to the individual. So this is how it's done, and this is the basic basic last for that I have designed to run the real-time interface as well. So apparently this is how it's done, and I've set my knowledge base to HRAG to response from the large language model. So that is why RAG is one of those domain which is not only an active area of search industry but also wisely used. Thank you.